For Stats 2023, this is Chapter 7, Section 2, Example 5. This is dealing with hypothesis testing. This is where sigma is known, so it's a z-test, just like you got through doing with Chapter 6 in the confidence intervals. So whenever sigma is known, we're doing a single z-test. The problem we're working on is example 5 in the book, and it says, according to a study of U.S. homes that are use heating equipment, the mean indoor temperature at night during winter is 68.3 degrees Fahrenheit. So it says you think this information is incorrect. So your claim is you think this information is correct. So our null hypothesis becomes equal to 68.3. Our alternative becomes it's not equal to 68.3, and that is our claim. Okay, because that's what the individual in the problem is claiming. Come back down. It says you randomly select 25 U.S. homes, so there's our N, that using heating equipment in the winter and find the mean indoor temperature at night to be is 67.2 degrees. There's our X bar. From past studies, the population standard deviation is known to be 3.5 degrees Fahrenheit. The population is normally distributed. Is there enough evidence to support your claim at alpha 0.05? All right, so what happens here is that there's our null hypothesis again, equal, our alternative at not equal. There's our X bar at 67.2. There's our mu, which is 68.3. Notice that our mu is always in the hypotheses, which is our population mean. There's our sigma. There's our n. There's our alpha. So these are the only values we need to solve this problem right here. Okay. Remember, the claim is that it's not 68.3. Okay. All right. So when we do this on the calculator, we're going to the z-test on the calculator. Make sure you have the stats button on. We're going to put the 68.3 in for mu, 3.5 in for sigma, 67.2 in for X bar, 25 for n. Now remember that the mu here is for the alternative hypothesis. So our alternative hypothesis is not equal to, so we want to make sure we have a not equal to here. So then we can come down to calculate. I can hit enter. And now you can see that z equals negative 1.57, and I'm only going to go to 2 decimal places. P is 0.116, and then it lists X bar and N again. So that what happens here is there's our Z, there's our P. We now see that P is greater than alpha. See, P is 0.116, alpha is 0.05. So the 0.116 is greater than 0.05. Anytime P is greater than alpha, we fail to reject HO. By failing to reject HO, we are not accepting the alternative. So our interpretation here is there is not enough evidence to support the claim, because there's not enough evidence to support the alternative hypothesis. Had P been less than 0.05, we would have rejected the HO, and the HO says that it's equal to 60.83, which means we would have supported the claim. In this particular example, P is greater than alpha, so we fail to reject, which means we basically accept the null hypothesis. By accepting the null hypothesis, we have no support for the claim.